Ever wondered how scientists predict the behavior of gases? Like how much pressure is in a compressed air tank or how hot a gas gets when you squeeze it? Today, we are going to unlock the secret equation that helps us to do just that. The ideal gas law. It is one of the most fundamental relationship in the chemistry and the physics, and by the end of this video, you'll understand exactly what PV is equals to nRT means. How to use it? So let's dive into it. The moment you have been waiting for, here it is, the famous ideal gas law. Let's break down what each of these letters stands for. P. P stands for pressure. This is the force exerted by the gas particles per unit area on the container walls. Common units includes atmosphere, kilopascal, and millimeters of mercury. V stands for volume. It is the space that gas occupies. Usually it is measured in liters or cubic meters. Remember, gases expand to fill their containers. N represents number of moles. This represents the amount of gas. Moles are a way to count the number of particles, atoms or molecules. One mole is Avogadro number of particle, which is 6.022 into 10 to the power 23. The gas constant R and the temperature T are the two crucial parts. T stands for temperature. It is a measure of average kinetic energy of the gaseous particles. It's very important that for ideal gas laws, temperature must be in Kelvin. To convert the temperature from Celsius to Kelvin, we just need to add 273.15 into degrees Celsius. Now the question is, why Kelvin? Because Kelvin scale is an absolute temperature scale, where 0 Kelvin means particles have minimum kinetic energy, and using Celsius would mess up our proportionality. Next we have is the ideal gas constant. This is a proportionality constant, and the fixed value makes the equation works. This value depends upon the unit you use for pressure and volume. For most high school chemistry problems, we use R as 0.0821. Why ideal gas only? What are the assumptions and the limitations? You might be thinking, why is it called the ideal gas law? Does that mean there are real gases? So as far as we know, we have already studied the assumptions of ideal gas. The ideal gas law works perfectly for a hypothetical ideal gas which follows specific assumptions that are from kinetic theory. First, the gas particles have negligible volume compared to the container. Second, there are no attractive or repulsive forces that exist between the gaseous particles. The collisions are perfectly elastic, and this shows that there is no loss in energy. But in in reality, no gas is perfectly ideal. Ideal gas particles do have some volume and there are weak attractive forces between them. These derivations become more significant at high pressure and low temperature. At high pressure, particles are squeezed closer, so their own volume becomes less negligible, whereas at low temperatures, particles move slower, allowing attractive forces to have more of an effect. However, for most everyday conditions, like moderate temperatures and pressure, ideal gas law works in an excellent approximation. So in order to understand that how this works or how we actually use PV is equals to nRT, let's look at a practical example. This law is used everywhere from designing airbags to understanding scuba diving tanks. We can also have a look at this graph. This graph suggests that the ideal gas behavior and the real gas behavior slightly different from each other. Whereas the ideal gas shows that PV by nRT should equals to 1. So when we draw the graph, we get a straight line. But for real gas, the line is not straight. It shows some deviation from the ideal behavior. But again, remember the conditions at low pressure and high temperature. They do behave as real gases. So the example problem here we have says that imagine we have a tank of oxygen gas with a volume of 50 liters. If it contains 2.5 moles of oxygen at a temperature of 25 degrees Celsius, what is the pressure inside the tank? So let us try to see the step-by-step procedure to follow such questions. First of all, we need to understand that what are the things given here and what we actually need to find. So here if you see, pressure is something which is missing. This is something which is unknown. This is something we have to find. But what we have volume, which is supposed to be 50 liters. We have number of moles, which is supposed to be 2.5 mole. We also have the value of R. As I said, we'll be using 0.0821 and the temperature says 25 degrees Celsius. So the first thing here we need to do is to convert the temperature from degree Celsius to degree Kelvin. So how we are supposed to do that? By just adding 273.15 into it. So when we does this, we get the temperature as 298.15 kelvins. Now rearrange the ideal gas law to solve the unknown. So basically we want to find out the value of P. So we rearrange pressure equation and substituting all the values into it like 2.5, 0.0821, 298.15 by volume that is 50 liters. So on solving all this, we can say that the pressure inside the oxygen tank is about 1.22 atm, or you can say atmosphere. See that PV is equals to nRT, you can predict gas behavior like a pro. You have it now, the ideal gas law, PV is equals to nRT. It is a key to understand that how gases behave. Remember its component: pressure, volume, moles, gas constant, and temperature. That should be always be in Kelvin. While it is based on ideal gas, it is incredibly useful for predicting the behavior of real gases in most everyday situations. You can also share this video with your classmates to help them understand the ideal gas law. Please hit that like button, share it with your classmates. Don't forget to subscribe for more easy to understand science tutorial. What other gas laws or chemistry topic or even physics topic I should cover next? Let me know in the comment below. Thanks for watching and keep exploring the amazing world of science.